Hello everyone, myself Dr. NCH Ramgopal, working as Associate Professor in Mathematics in the Department of Humanities and Sciences, MLR Institute of Technology, Hyderabad. I welcome you all to the today's session on Stokes Theorem Part 2. In the last session, I have introduced one of the vector integral theorems called Stokes Theorem, and the statement of Stokes Theorem is the line integral. The Stokes Theorem converts a line integral into a surface integral. In the last session, we have verified the Stokes theorem for the given vector function. Today, I am going to continue the same topic, and today I would like to apply the Stokes theorem to evaluate a line integral or to evaluate a surface integral. What is the use of this Stokes theorem? For example, if a line integral is given, to evaluate this, instead of evaluating line integral, we convert it into a surface integral. Or else, if a surface integral is given, using Stokes theorem, we can convert it into a line integral also. Now, the Stokes theorem states that the line integral f bar dot dr bar is equal to surface integral curl f bar dot n bar ds. So, if you want to evaluate line integral, you need to calculate f bar dot dr bar. Similarly, if you want to solve the problem by finding surface integral, you need to find curl f bar dot n bar ds. Now, coming to the second problem, if f bar is y I bar plus x minus 2xz j bar minus xy k bar, evaluate the surface integral where S is the surface of the sphere above the xy plane. So, here the problem is to evaluate the surface integral. And for example, if the question is using Stokes theorem, then we can apply the Stokes theorem. Instead of evaluating a surface integral, we can evaluate the line integral. Now, first write the given. F bar is y I bar plus x minus 2xz j bar minus xy k bar. Now, by Stokes theorem, the surface integral curl f bar dot n bar ds is equal to line integral f bar dot dr bar. So, instead of finding surface integral, we can evaluate the line integral. To evaluate this line integral, first we need to calculate f bar dot dr bar. So, we have r bar is xi bar plus yj bar plus zk bar. But in xy plane, the value, what is the value of z? The value of z is 0. Therefore, r bar is xi bar plus yj bar. And what is dr bar? dxi bar plus dyj bar. Now, let us calculate f bar dot dr bar, the dot product between these two vectors. What is the given vector f bar? Y I bar plus x minus 2xz j bar minus xy k bar. So, in xy plane, z is 0. So, therefore, f bar will be y I bar plus x j bar. Since z is 0, there will not be the third component. Now, the dot product between this f bar and dr bar. So, y I bar plus x j bar, y dx plus x dy. So, this is f bar dot dr bar. Now, we need to evaluate the line integral of this f bar dot dr bar. Line integral means, so line integral f bar dot dr bar means we need to integrate with respect to one variable only, either in x or in y or both in terms of some other theta or phi or any other. So, here we need to transform either y to x or x to y or both x and y in terms of some other parameter. And what is the given curve here? So, surface of this sphere, the sphere is given. So, given surface is x square plus y square plus z square is a square. Since z is 0 in xy plane, this becomes x square plus y square equal to a square. since z is 0. Now, so using Stokes theorem, the surface integral curl f bar dot n bar ds is equal to the line integral f bar dot dr bar. So here we must have the integrand in terms of single variable. For that reason, I will consider the substitution method or the transformation. Would x equal to a cos theta, y equal to a sin theta. That means we are transforming both x and y to theta. So we need to transform dx and dy also. So what is dx? A is constant, cos theta derivative is minus sin theta. So minus a sin theta d theta, and dy is a cos theta d theta. And theta changes from 0 to 2 pi. Theta lies between 0 and 2 pi. So here the line integral f bar dot dr bar, that just now we have calculated, y dx plus x dy. And what is y? Y is a sin theta multiplied by dx minus a sin theta d theta, plus x is a cos theta multiplied by dy a cos theta d theta, where theta from 0 to 2 pi. Now, by simplifying this, here we get minus a square sin square theta. So that is equal to theta from 0 to 2 pi minus a square sin square theta, here a square cos square theta, sin square theta plus a square cos square theta d theta. So which is theta from 0 to 2 pi. I can take a square common. So what remains? Cos square theta minus sin square theta d theta. And what is this cos square theta minus sin square theta? We have the formula for cos 2 theta is cos square theta minus sin square theta. So I can replace this term cos square theta minus sin square theta by cos 2 theta d theta. And what is the integral of cos sin 2 theta by 2 from 0 to 2 pi? By applying the limits a square by 2 into sin 4 pi minus sin 0. And we know that sin n pi is 0. So therefore, the answer is 0. Sin n pi is 0 where n belongs to z, integers. For negative integers, positive integers including 0, sin n pi is 0. Hence the surface integral del cross f bar dot n bar ds is equal to 0. Now coming to this third problem, verify Stokes theorem for the given f bar where S is the circular disk. So again, verification problem. The previous one is an application. Instead of finding surface integral, we have converted it into a line integral. And with the transformation, x equal to a cos theta, y equal to a sin theta, in a simple way, we have evaluated the line integral. And here, we need to verify Stokes theorem. What is Stokes theorem? To verify Stokes theorem, we have to show that the line integral f bar dot dr bar is equal to surface integral curl f bar dot n bar ds. So that means we need to calculate LHS and then RHS, and finally we have to prove that both LHS and RHS are the same. Let us consider LHS. Integral f bar dot dr bar along the curve C. So the line integral. Now first we need to calculate this f bar dot dr bar. So we have, what is r bar? xi bar plus yj bar. Clearly it is given that z equal to 0, that indicates or that represents the xy plane. In xy plane, z is 0. So dr bar is dxi bar plus dy j bar. Now f bar dot dr bar is, so this first component and the first component in r bar, dr bar. So minus y cube dx plus x cube dy. This is f bar dot dr bar. Now again here, f bar dot dr bar is a function of two variables. But here we are calculating the line integral. Line integral means with respect to one variable only we can integrate. So let us transform the variables. Put x equal to cos theta, y equal to sin theta. Because here the disk is x square plus y square equal to 1 with radius 1. So I can take the radius as 1. Now that implies dx is minus sin theta d theta, dy cos theta d theta, and theta changes from 0 to 2 pi. Now substituting this in the given line integral, so the LHS is equal to integral c f bar or dr bar, which is integral minus y cube dx plus x cube dy along the curve C, but here we are using the transformation theta in terms of theta. So theta varies from 0 to 2 pi. And what is y? X equal to cos theta, y equal to sin theta. So minus sin cube theta and dx. dx is x is cos theta, so minus sin theta d theta plus x is cos theta, so cos cube theta into dy. So dy is cos theta d theta, cos theta d theta. So which is equal to theta from 0 to 2 pi minus into minus plus sin power 4 theta plus cos power 4 theta d theta. So which is in the form, we can write this as sin square theta whole square plus cos square theta whole square d theta. So we have the formula a plus b whole square is a square plus b square plus 2ab. From this, since this is in the form of a square plus b square plus b square is a plus b whole square minus 2ab. So let us use this here. That is equal to theta from 0 to 2 pi. Now a plus b whole square, a is sin square theta, so this is a, this is b, a plus b whole square, so sin square theta plus cos square theta whole square minus 2 into a into b, sin square theta into cos square theta d theta. Now everything is in terms of theta and we can integrate. So here theta from 0 to 2 pi, we know that sin square theta plus cos square theta is 1. So 1 minus 2 sin square theta cos square theta d theta. Now let us split this into two parts. 1 into d theta. So theta from 0 to 2 pi minus multiply and divide by 2. Then here we get 4 sin square theta cos square theta d theta from 0 to 2 pi. So integral d theta, these two gets cancelled. Since the integration is the reverse process of differentiation, here we get only theta from 0 to 2 pi minus 1 by 2 into, I can write this as 2 sin theta cos theta whole square. So this is 2 pi minus 1 by 2 into integral 0 to 2 pi. This is 2 sin theta cos theta is sin 2 theta. So sin square 2 theta d theta. So that is equal to 2 pi minus 1 by 2 into integral 0 to 2 pi. Now again, cos 2 theta is 1 minus 2 sin square theta. So 2 sin square theta is 1 minus cos 2 theta. So sin square theta is 1 minus cos 2 theta whole divided by 2. But here we have sine square 2 theta. In place of theta, we have 2 theta. So, sine square 2 theta is equal to 1 minus cos 4 theta by 2. So, this is 1 minus cos 4 theta whole divided by 2. So, this is 2 pi minus half into, again splitting into 2 parts, integral d theta. So, this 2 comes out. So, 4 minus integral cos 4 theta d theta, and the limits from 0 to 2 pi. So, this is equal to, so which is equal to 2 pi minus 1 by 4 into integral d theta is theta from 0 to 2 pi, then minus into minus plus 1 by 4 into integral of cos 4 theta is sin 4 theta by 4, sin 4 theta by 4 from 0 to 2 pi. So, 2 pi minus, this is 2 pi by 4 plus 1 by 4 into sin 8 pi minus sin 0 by 4. And we know that sin n pi is 0. So, 2 pi minus pi by 2 plus 1 by 4 into sin 8 pi. Sin n pi is 0. Sin n pi is 0. Therefore, this is 0. So, 2 pi minus pi by 2, 3 pi by 2. This is LHS. Now, we need to evaluate the RHS also, and finally, we have to prove that RHS is equal to 3 pi by 2. Now, coming to RHS, what is RHS? Surface integral curl f bar dot n bar ds. So, what is curl f bar? Curl f bar is del cross f bar, which is I bar, j bar, k bar, dou by dou x, dou by dou y, dou by dou z, and the components of f bar. What is f bar? Minus y cube plus x cube. So, minus y cube plus x cube 0. Now, let us find the determinant I bar into 0 minus j bar into dou by dou x of 0 and dou by dou z of y cube. Since y is constant, we treat y as constant while differentiating with respect to z, that is also 0, plus k bar into dou by dou x of x cube 3x square minus, again here we have minus, so plus y 3y square. So, 3 k bar into x square plus y square. So, this is curl f bar. Now, for xy plane, the outward drawn unit normal vector is k bar. So, therefore, curl f bar dot n bar is 3 k bar into x square plus y square dot k bar, which is 3 into x square plus y square. Now, we need to find the limits, because surface integral means we need to evaluate the double integral. So, with respect to two variables, we have to integrate. If you have x and y limits directly given in the problem, then well and good. Otherwise, we need to use some substitution method. So, the polar form, transformation from Cartesian to polar form. So, put x equal to r cos theta, y equal to r sin theta. So, if we use this, simply polar form r comma theta notation, and r changes from 0 to 1, theta changes from 0 to 2 pi. So, and also ds is r dr d theta. So, in fact, here we can use that phi notation also, r dr d phi also. Now, if x is r cos theta, dx is minus r sin theta d theta, dy r cos theta d theta. Substituting all these, we get RHS is surface integral f bar curl f bar dot n bar ds, which is double integral. What is curl f bar dot n bar? 3 into x square plus y square. 3 into x square plus y square. So dx dy. But here we are using the notation, or we are transforming these to theta and r and theta. So theta from 0 to 2 pi, r from 0 to 1. I can write this constant outside. And what is x? R cos theta. So r square cos square theta plus r square sin square theta. Dx is minus r. Okay. Dx dy. So here in fact we don't need these values. Now we need to find the limits. If x and y limits are given directly, well and good. Otherwise we need to use some substitution method. Here put x equal to r cos phi, y equal to r sin phi, then dx dy is r dr d phi, then theta changes from 0 to 2 pi and r changes from 0 to 1. So let us use this to evaluate the RHS. What is RHS? Surface integral curl f bar dot n bar ds. So which is surface integral 3 into x square plus y square dx dy, but which is 3 times of theta from 0 to 2 pi, x from 0 to r from 0 to 1, x square, r square, here it's not theta, phi from 0 to 2 pi, r from 0 to 1, r square cos square phi plus r square sin square phi, and dx dy is r dr d phi. So 3 into phi from 0 to 2 pi, r from 0 to 1. Here we can take r square common, then sin square phi plus cos square phi is 1. So r square into r cube dr d phi. So which is 3 into phi from 0 to 2 pi. Now integration with respect to r power 4 by 4 from 0 to 1 dr. So which is equal to 3 by 4 into integral 5 from d phi. So that is equal to 3 into 5 from 0 to 2 pi, 1 by 4, upper limit is 1 d phi. 1 by 4 is constant, so 3 by 4 integral d phi from 0 to 2 pi. And these two gets cancelled. So 3 by 4 into phi from 0 to 2 pi. Applying the limits, here we get 2 pi, so which is 3 pi by 2. And what is our, this is RHS. What is our LHS? Is 3 pi by 2. And RHS is also 3 pi by 2. So therefore, LHS is equal to 3 pi by 2, which is equal to RHS. Hence, Stokes' theorem is verified. So this is about vector integral theorems. We have discussed about the Gauss divergence theorem, Green's theorem and Stokes' theorem, and solved some problems on these three theorems. Thank you.